The critical path is the backbone of project scheduling and one of the most reliably tested topics on the PMP exam. In this video, I'll break down the critical path method completely. We'll cover what the critical path is, how to build a network diagram, how to run the forward pass and backward pass step by step, how to calculate float, and how to identify the critical path. I'll finish with a practice question. By the end of this video, CPM will be one of the topics you look forward to seeing on the exam. Let's get into it. The critical path is the longest sequence of dependent activities from project start to finish. It determines the minimum project duration. Two things define the critical path. First, it is the longest path through the network. Second, activities on the critical path have zero float. Float is the amount of time an activity can be delayed without delaying the project. On the critical path, any delay to any activity delays the entire project. The exam tests CPM in two ways: calculation questions, where you find the critical path and compute float, and scenario questions where you apply CPM thinking to scheduling decisions. The critical path method uses a network diagram to map activities and their dependencies. The standard format on the PMP exam is activity on node, AON. Each activity is a box. Arrows connect boxes to show dependencies. Each node contains activity name, duration, early start, early finish, late start, and late finish. The forward and backward passes calculate those four values. Dependencies follow four types. Finish to start is the most common. One activity must finish before the next starts. Unless the question specifies otherwise, assume finish to start. 5 terms to know cold before running the passes. Early start, ES, the earliest an activity can begin. Early finish, EF, equals ES plus duration. Late start, LS, the latest an activity can begin without delaying the project. Late finish, LF, the latest it can end. LS equals LF minus duration. Float, also called slack, equals LS minus ES, or LF minus EF. Both give the same result. Zero float means the activity is on the critical path. Here's our example network. 6 activities, A, B, C, D, E, and F. 3 paths. Path 1, A, then C, then E. Path 2, B, then D, then E. Path 3, B, then F. Durations: A, 3 days. B, 5. C, 4. D, 3. E, 2. F, 6. Path 1 totals 9 days. Path 2 totals 10. Path 3 totals 11. Path 3 looks longest. Let us confirm with the forward and backward pass. The forward pass moves left to right, start to end. It calculates early start and early finish for every activity. 2 rules. Rule 1, the first activity's ES equals 0. Rule 2, when an activity has multiple predecessors, its ES equals the maximum EF of all predecessors. It cannot start until all predecessors are complete. Early finish always equals early start plus duration. Apply left to right through every activity. Activity A, ES 0, duration 3, EF 3. Activity B, ES 0, duration 5, EF 5. Activity C, predecessor A has EF 3, ES 3, duration 4, EF 7. Activity D, predecessor B has EF 5, ES 5, duration 3, EF 8. Activity E, 2 predecessors, C with EF 7 and D with EF 8. Maximum is 8. ES 8, duration 2, EF 10. Activity F, predecessor B with EF 5, ES 5, duration 6, EF 11. Project early finish equals the maximum EF of all terminal activities, 11 days. The backward pass moves right to left and to start. It calculates late finish and late start for every activity. 2 rules. Rule 1, the last activity's LF equals the project early finish, 11. Rule 2, when an activity has multiple successors, Its LF equals the minimum LS of all successors. It must finish in time for the earliest successor. Late start equals late finish minus duration. Apply right to left. Activity F, LF11, duration 6, LS5. Activity E, LF11, duration 2, LS9. Activity D, successor E with LS9, LF9, duration 3, LS6. Activity C, successor E with LS9, LF9, duration 4, LS5. Activity B, two successors, D with LS6, F with LS5, minimum is 5, LF5, duration 5, LS0. Activity A, successor C with LS5, LF5, duration 3, LS2. All 6 activities now have ES, EF, LS, and LF. Now calculate float. Float equals LS minus ES. Activity A, 2 minus 0, float 2, not critical. Activity B, 0 minus 0, float 0, critical. Activity C, 5 minus 3, float 2, not critical. Activity D, 6 minus 5, float 1, not critical. Activity E, 9 minus 8, float 1, not critical. Activity F, 5 minus 5, float 0, critical. Critical path, start, B, F, end, duration 11 days, confirmed. B and F have 0 float. Any delay to either delays the entire project. The exam distinguishes between 2 types of float. Total float is what we just calculated, how much an activity can slip without delaying the project end date. Total float is shared across a path. If one activity uses its total float, connected activities on the same path lose their float too. Free float is how much an activity can slip without delaying its immediate successor. Free float equals the early start of the next activity minus the early finish of the current one, always less than or equal to total float. Exam rule project delay question, use total float. Next activity delay question, use free float. The critical path is a decision-making tool, not just a calculation. Any delay to a critical path activity delays the project by the same amount. Crashing and fast-tracking only shorten the project if applied to the critical path. Working on non-critical activities has no effect on the end date. The critical path can change during execution. If a non-critical activity uses all its float, it becomes critical. Project managers monitor the critical path continuously. Near critical paths, paths with very little float, are a schedule risk. The exam tests whether you manage them proactively alongside the critical path. 2 compression techniques apply when the schedule must be shortened. Both target the critical path. Crashing, adding resources to shorten critical path durations. Crashing costs money. Crash the activity with the greatest time reduction for the lowest additional cost. Only crash critical path activities. Crashing non-critical ones waste money without shortening the project. Fast tracking, overlapping activities planned in sequence. No direct cost, but increases risk. Only works where overlap is logically possible. Exam rule, if both options are available, fast track first. If you must crash, focus exclusively on the critical path. 4 traps on CPM questions. Trap 1, confusing longest by duration with most activities. Critical path is longest by total duration, not by activity count. Trap 2, the merge point rule. Multiple predecessors feed one activity, always take the maximum EF on the forward pass. Missing this makes everything downstream wrong. Trap 3, the burst point rule. One activity feeds multiple successors, always take the minimum LS on the backward pass. Trap 4, Ignoring near-critical paths. The exam describes near-critical paths becoming critical during execution. The correct answer manages them proactively, not reactively. Exam-style question. A project network has 3 paths. Path 1, 14 days. Path 2, 18 days. Path 3, 16 days. An activity on Path 2 has 0 float. An activity on Path 3 has 2 days of float. The project manager must shorten the schedule by 3 days. What should the project manager do? Option A. Crash activities on Path 1. It has the most float. Option B. Fast-track activities on Path 3. It has available float. Option C. Focus compression efforts on Path 2. It is the critical path. Option D. Crash all 3 paths equally to distribute schedule risk. The correct answer is C. Path 2 has 18 days duration and a 0 float activity that makes it the critical path. To shorten the project, you must compress the critical path. Non-critical paths do not control the end date. Why not A? Path 1 at 14 days is not critical. Compressing it has no effect on the project end date. Why not B? Path 3 has float and is not critical. Fast-tracking it reduces its float but does not shorten the project. Why not D? Crashing all paths equally is wasteful. Only the critical path controls project duration. C is correct because schedule compression must always target the critical path. That is your complete guide to the critical path method, network diagrams, forward pass, backward pass, float, and schedule compression. Save this video for your exam review. Subscribe for more PMP exam prep. Next up, how to eliminate wrong answers on the PMP exam. See you in the next video.